Hi, my name is Gene Kim, and I've been studying high-performing technology organizations for 25 years. And so this was a journey I started back when I was the CTO and founder of a company called Tripwire in the information security space. And so the goal was to understand how these amazing organizations simultaneously had the best project due date performance and development. They had the best operational reliability and stability in operations, as well as the best posture of security and compliance. And so naturally, we wanted to understand how did those amazing organizations make their good to great transformation, so that we could understand how other organizations could replicate those amazing outcomes. And so, as you can imagine, in a 25-year journey, there were many surprises. But by far, the biggest surprise was how it took me into the middle of the DevOps movement, which I think is so urgent and important. I think the last time that any industry, any organization has been disrupted to the extent that all our organizations are being disrupted today was likely manufacturing in the 1980s, when in the US automotive marketplace, Toyota entered the market and upended the entire automotive market. And I think that's exactly what DevOps is. You take those same lean principles, apply them to the technology value stream that we work in every day, and you end up with these emergent patterns that allow tens, hundreds, or even hundreds of thousands of deployments per day without causing chaos and disruption. So, yeah, I can't overstate just how much I've learned in the last 25 years. And the Phoenix Project came out in 2013, and I got to work with Dr. Steven Spear from the MIT Sloan School of Business, who made his career studying the Toyota production system. So what I'd like to do is now share my slides. Rick, if you can give me a visual cue that you can actually see my slides. Click here, share screen, go to window, and I'm hoping that you will see my slides. Rick, can you give me a thumbs up? Okay, fantastic. Thank you. All right. So here's what I'd like to present in the next 45 minutes or so. One is share with you what I learned doing the State of DevOps Research. This is the work I got to do with Dr. Nicole Forsgren and Jez Humble. It's a cross-population study that spanned over 36,000 respondents over 6 years, where we learned what high performance looks like. I want to share with you what I've been working on in the last 4 years, specifically the work that I got to do with Dr. Steven Spear, who was part of this second generation of researchers who deeply studied the Toyota production system, culminating in this famous, probably the most widely downloaded Harvard Business Review article of all time called Decoding the DNA of the Toyota production system. And this came out into a book that came out last year called Wiring the Winning Organization. And I can't overstate how much I learned. It was the most intellectually challenging thing I've ever worked on, but it was also most rewarding because I learned so much about the fundamental mechanisms at work, whether you're talking about the Toyota production system or DevOps. So let's talk about the business value that DevOps created. So as I had mentioned, this is a cross-population study that spanned 36,000 respondents. And so this is the same instrument that the medical community used to establish the link between smoking and early morbidity and mortality. And so here's what we learned over 6 years, is that high performers exist and they massively outperform their non-high performing peers. As measured by what? We know that high performers are deploying more frequently. They're deploying multiple times per day. So that's 2 orders of magnitude more frequently than their peers. But more importantly, they can do those deployments more quickly. So how quickly can they go from code being put into version control, and not just by developers, but infrastructure, operations, security, everybody, through integration, through testing, through deployment, so that customers are actually saying thank you. And high performance can do it in 1 hour or less. And that's, again, 2 orders of magnitude faster than their peers. More importantly, when they do deployments, they get far better outcomes. They are 7 times more likely to succeed without causing a 7-1 outage, a service impairment, a security breach, or compliance failure. And when bad things happen, which Murphy's Law guarantees, they can fix those issues much, much faster in 1 hour or less, as measured by the mean time to restore service. And so this is 3 orders of magnitude faster than the peers. And so for 6 years in a row, we found these decisive findings, suggesting that the only way that you can get these amazing reliability profiles is to do smaller deployments more frequently. And so over the years, we looked at other dimensions of quality. We found that because information security objectives are being put into everyone's daily work, they spend only 1/2 the amount of time remediating security issues. So starting in 2014, we started looking at another dimension of performance. What we found is that these high performers, in addition to these amazing technology measures, also have better organizational performance. They are twice as likely to exceed profitability, market share, and productivity goals. And so people started asking, what about not-for-profits or government agencies or military services? We found the same multiple of performance. Those organizations are twice as likely to achieve organizational and mission goals, regardless of how they chose to measure it, whether it was customer satisfaction, quantity, or quality. And so for me, the finding was very clear. It said that if mission achievement requires the work that we do in the technology value stream, then DevOps helps with the achievement of those objectives. So there are other markers of organizational performance that we found. We found that in these high performers, employees are twice as likely to recommend their organizations as a great place to work to their colleagues and friends. And so in an age where recruiting and retention are so important, this has never been more important. And so it really does suggest, DevOps helps us safely, securely, quickly, reliably achieve all the goals, dreams, and aspirations of the organizations that we serve. So let me just do a little adjustment here. My area of passion for the last 10 years is studying DevOps, not so much in the tech giants, the Facebooks, Amazon, Apples, Netflix, Googles, Microsofts, but instead large, complex organizations that have been around for decades or centuries. And so this is the reason why we've held now 21 conferences called the DevOps Enterprise Summit. In the beginning, we said no unicorns allowed. This is a conference for horses, by horses. And the goal was for technology leaders to share experience reports of how DevOps is helping them win and compete in the marketplace. And it's been so rewarding for me to see that technology leaders from almost every industry vertical are using DevOps to compete and win, whether it's financial services, insurance, manufacturing, but also public administration, which is at the bottom, the second highest sector. And so you see DevOps showing up in so many surprising places. And so here are some of my favorites. Here's Captain Andy Bean showing how they are modernizing software update processes for the Aegis Missile Defense Program, where we can upgrade software without waiting for the ships to have to go into a major refit, often taking 8 years, cutting holes in the steel bulkheads, essentially paving the way for over-the-air updates for the radar systems at sea. Siemens Healthineers. This is Thomas Yachman, head of software for computed tomography at Siemens, describing how they were able to go from being able to have certification-ready software once every 6 months to potentially being ready every day to trigger a certification cycle, again, paving the way to upgrade 6,000 CAT scanners in the field. And so it's amazing to me that that in these CT scanners, the component that dictates whether they get 0.5 kilowatts of radiation or 100,000 watts of radiation is entirely software controlled. So this is important, so important to get right. And earlier this year, we had Jamie Hook and Laura Tocco talk about how they are elevating the productivity of thousands of developers at Pfizer, our first pharmaceutical case study, showing how they're helping developers help with every stage of the pharmaceutical development process, whether it's from early exploratory design to development to rollout to sales and marketing. So all of these, I think, give us confidence that DevOps is indeed for everyone. So what I'd like to do next is share what I've been working on for the last 4 years. And so this is Dr. Stephen Spear, who I met 10 years ago when I took a workshop from him at MIT. And this is that famous paper I mentioned, Decoding the DNA of the Toyota Production System. And I remember reading this. It was one of my Phoenix Project co-authors, Kevin Baer, in about 2001, reading this paper, marveling at how people in the Toyota Production System are all solving problems all the time, participating in a community of scientists. So I cannot tell you how rewarding it's been to study deeply Toyota Production System and DevOps and try to find a common mechanism. And that is what resulted in this book at the bottom called Wiring the Winning Organization that came out in November of last year. And so our goal was really to answer 2 questions. One is, why do organizations work, both in the ideal and not ideal? And what is in common between Agile, DevOps, Toyota Production System, Lean, and for that matter, resilience engineering, safety culture, psychological safety, Conway's Law, and so much more. And our conclusion is that they are all incomplete expressions of a far greater, but also simpler whole, that at the heart of every one of these methodologies, there's only really 3 mechanisms of work that enable high performance. And I have so much admiration for the DASA body of knowledge. And so absolutely the practices, the knowledge, all fits into that center of just as DevOps would predict. And so what I learned working with Dr. Steven Spear is that there is a magic that high-performing organizations have. And we can describe them in 3 dimensions. The first dimension is that everyone is solving important problems all the time, ideally in parallel. And that's because everyone has what they need, when they need it, in the right format, at the right time, from the people who they expect. And that's because they have the information they need, approvals, requirements, decision rights, materials from the right people at the right time. So the not ideal case is the opposite end of the performance spectrum. Everyone is stuck because no one has what they need to get done. They don't have what they need, when they need it, in the right format, at the right time. And so the result is that even small efforts require superheroic efforts. So one of my favorite examples of this came from a friend of mine. We put this into a paper that we call the Checkbox Project. And so imagine a mobile telco carrier where the top initiative of the year is to put a checkbox in front of their 20 million customers so they can opt into a $5 a month service for things like email or watching movies. The problem is that this requires work from 20 different teams across 4 different channels to the customer. It requires CEO -1 level support, requiring daily war room meetings, project managers, escalations, cajoling, politicking. It is estimated to cost $28 million, 12 months. And the worst part is, the bad part is that most people give it only a 20% odds of success. Why? Because the last 2 times they tried this, it failed. And so what's incredible here is that this is not necessarily the most technically challenging problem. Instead, it is because that no one has what they need when they need it. It is all in the cost of coordination. So that's one dimension of performance. The second one is around energetic feedback loops. So in the ideal, everyone has feedback where even weak failure signals are amplified so they can be acted on quickly. So they can quickly detect, quickly correct, and ideally prevent it so it won't happen again. And when you have rich feedback, people can learn because whether you're learning a musical instrument or learning a programming language, you need feedback. This is at the core of deliberate learning. And this is made possible when feedback goes to the right people at the right time in an actionable format. So let's explore what the not ideal looks like. Feedback loops are weak, slow, non-existent, or go to the wrong people. So this is the bad old days where for developers to get production logs, they would have to open up a ticket and maybe wait days. And when this happens, failures go undetected and actually grow over time. So failures snowball. Or there's another aspect where signals are generated, but somehow the system suppresses them or even extinguishes them entirely. So because everyone's afraid to tell bad news. So that's obviously not so good. And maybe some of us have friends where leaders set norms where that is what happens. That is absolutely not ideal. So the third dimension of performance is that there's enough time in the schedule for planning, practice, and experimentation and improvement. That we have practice environments where we can do the most dangerous operations with lower stakes so people can safely fail, learn, and improve. And even better, there's actually mechanisms in place so we can capture lessons learned throughout the process so we can actually get better at what we do. So what does not ideal look like is that we have to do our most highly consequential, dangerous work in the most high stakes environment there is, which is production, where we have no ability to redo, no ability to undo, and we have unacceptably high consequences of failures. And so this is a real problem because learning requires experimentation and iteration. Under these conditions, no one can learn. And so another aspect of this is that there's no time to pause in production, to slow down, to speed up, to stop sawing, to sharpen the saw. And so something that Steve said to me about 2 years ago, which I initially was not a big fan of, but I think is a very important insight, is that there's really 3 layers of which we do work. Layer 1 is work in front of us. So in our work, it could be code inside it could be the code. It could be the binary running in production. It could be the patient in front of us. Layer 2 is the technology. So this could be the IDE in which we are modifying the code. It could be the Kubernetes platform of which is running the production binary. It could be the CAT scanner, the MRI machine, the blood tracing machines. And the third layer is, however, the difference maker. This is the social circuitry, the organizational wiring of how we connect people and teams together that dictates who they can talk to, when, in what format, in what protocol, to enable joint cognition and problem solving. And so in almost any story where an organization goes from worst to first, the only thing that changes is in layer 3, that everything else in layer 1 and layer 2 remain the same. So think about the famous NUMMI joint venture between Toyota and General Motors. So that was based on the automotive plant in Fremont, California. This was not only the worst performing GM plant, but it was actually one of the worst performing plants around the globe. So when this became the site of the joint venture with Toyota, within a year, it became one of the best performing plants on par with any other Toyota plant that was operating in Japan. What changed? Same people, same floor space, same capital equipment, same technology. The only thing that changed was the management system. And so too, when we see a DevOps transformation, there might be some automation, but primarily it is about how we wire the teams together, their incentive models, the habits, the norms, routines, of how people solve problems together. And so what we're suggesting in the Wiring the Winning Organization book is that there's only 3 mechanisms of performance. One is the ability to slowify, to solve problems not in production, but during planning and practice. The second mechanism is to change the nature of the problems themselves so that they are easier to solve. And we do that through partitioning, decoupling, or by linearizing, which makes the problem inherently easier and safer to solve. And the third is around amplification, creating a system where we can reduce noise in the system and amplify important signals so they can be decisively acted upon to quickly correct, detect, and ideally prevent. So let's just put aside all this fancy talk. What is this really about? How can we make this simple so that anyone, even our highest level leaders, can understand? And the metaphor that we came up with that I'm so proud about is 2 people moving a couch. And so let's call them Steve and Jean. And so you might think that this is all brawn work. In other words, there's no brain work needed. And yet Steve and Jean have to solve a lot of, come up with answers to a lot of non-obvious problems. For example, where exactly is the center of gravity? To get through a narrow doorway, around which axis do they rotate? To get through a narrow winding set of stairs, who should go first? And should that person face forwards or backwards? And what's amazing is that they don't need to bring in a bunch of consultants or write a bunch of requirements documentation or run focus groups. Just by picking up the couch, trial and error, fast feedback, experimentation, but most importantly, communication and coordination, we can have some confidence that Steve and Jean will figure out how to get done what needs to get done. But what is remarkable is that as leaders, there are many things we can do that to make their jobs more difficult. For example, we can turn off all the lights. So suddenly the work will take longer. It will be more dangerous. They could damage the furniture, the rooms around them, or maybe even themselves. So that's not so good. But we can add a different dimension of difficulty, which is introducing a lot of background noise, like a loud siren or loud music. Or we can even introduce an intermediary that prevents Steve and Jean from talking directly to each other. Instead, we will make them go through JIRA tickets or work orders or requirements documents or project managers or contract account managers or lawyers. And under this situation, suddenly it is not inconceivable that Steve and Jean will not be able to achieve their goal because the information needed to flow between them simply cannot exceeds the bandwidth available between that in that JIRA ticket, no matter how many fields we give them. And so I think this is exactly where DevOps came from, is that when deployments became sufficiently complex, the information that needed to get transmitted between dev and ops so far exceeded the ability for them to successfly achieve the goal together. And so I think that's exactly what dev and ops, this happens between business and technology. It's a story of team of teams and so much more. And so the reason why I'm so proud of this metaphor is that it really introduces 2 critical elements for joint problem solving, which is really what this metaphor is all about, is to what degree are 2 people able to solve a problem together. So the 2 properties needed are coherence, is to what degree are Steve and Jean able to act as a logical unified whole, which allows for logical and consistent behavior. And so if you if you impede their ability to communicate and coordinate, they are suddenly incoherent. And the second one is coupling, is that there's a difference between two people moving a couch versus two people moving two chairs independently, which require no need to communicate and coordinate, schedule, prioritize, deconflict, unless if they have to go through a narrow doorway together. So in which case it does require signaling, communication, coordinating. And so the job of us as leaders at all levels, to understand the difference of, are we solving a couch problem or are we solving a two-chair problem? So, so there are some places where we want lots of coupling, right? And this is maybe the big room planning. This is where the goal is to create a shared sense of goals and enable anyone to talk to anybody. But this is not how we want to do daily work. Instead, the way we want to get work done is in smaller teams where we can do our work independently without the need to communicate, coordinate, schedule, prioritize with scores of other teams. And so I love this because this judgment resonates with something that Dr. Ron Westrom, who created the Westrom organizational typology model, talked about. He introduced me to the term of the socio-technical maestro. He said, it requires 5 things: high energy, high standards, great in the large, or system thinkers, but also great in the small, so they can ask good questions, and they love walking the floor. And this had such huge explanatory power to me because it sometimes explained some of the best leaders I've seen, but also explained some of the worst leaders I've seen because they didn't have any of these characteristics. So what I'd like to do next is really walk through each one of these mechanisms of performance and describe some of the underlying theory, but some of my favorite examples, both in the DevOps and non-technology realms. So slowification is really about moving work in time so that we can do work not in the high-stakes production environment, but do them in the safer environments of planning and practice. And so one of my favorite examples of this in the book is the case of Miss Morris versus Miss Morrison. And so there are 24 case studies in the book, and only 20% are technology related. The ones that actually have the most case studies is actually healthcare, especially emergency departments, because emergency departments all around the globe are often the places where people just don't have the right information at the right time. And this leads to horrendous accidents. And so the probability of going into an emergency department and leaving worse than when you entered it is atrociously high. So this is a case where the wrong patient got operated upon, despite 14 signals that something was not quite right, including the patient saying, "You've got the wrong patient." And so in this case, at what should have happened is that when people saw things going wrong, they should have pulled the andon cord or stopped production and regained situational awareness of what is happening. And so instead of it, they missed 14 signals and operated on the wrong patient. And so there are so many great examples of how in healthcare systems, when you instead pause in production so you can modify the processes, you end up with far better outcomes, including driving down the rate of C-lab infections. So I guess this is infections when you put in an IV needle down to 0. And so in the technology space, we see very similar examples using the same mechanisms. One of my favorite examples happened in April 2011 during the first huge Amazon EC2 failure. This is when the US East 1 availability zone went down. This is where they put all their largest customers because it was their largest. And so when that went down, almost all their large customers went down, with one curious exception, which was Netflix, which is the reason why it's so curious and surprising is that Netflix for years was describing how they were running entirely in the Amazon cloud. So how could they keep running when EC2 and AWS East 1 went down? And the answer was revealed some days later in this famous blog post where they described essentially 2 design decisions they had made back in 2009 when they were starting their migration from their data centers to the public clouds. And the one decision was we can have no single point of failure risk. And the second one, of which they identified Amazon being the largest single point of failure. In fact, a friend of mine even said, they will never be there when we need them most. So the second design decision they made was that the only way they could survive failure reliably was to fail all the time. And so this is when they revealed the now famous chaos monkey, this incredibly audacious piece of code that randomly kills entire VMs, EC2 instances in the cloud during office hours. And so you can imagine if Netflix, you have developers who build it, who run it, right? If something's randomly killing things in the middle of the business day, they're going to be very motivated to make it more resilient so that it can survive those failures. By the way, I used to think that Chaos Monkey ran 24 hours a day. And my friend Adrian Cockcroft laughed at me. He said, no. At Netflix, enough things go wrong in the middle of the night that we don't need to add to that. Let's do it only during office hours so that we can fix these issues when everyone's still working. So Chaos Monkey runs entirely during office hours. A great testimony of how this saved them again was during the great Amazon reboot of 2014. This is when the entire server fleet had to be rebooted to apply a emergency Zen security patch at the hypervisor level. And so Christos Kalantzis from the cloud database engineering team said, when we got the news about the emergency EC2 reboots, our jaws dropped, especially when we saw the list of how many Cassandra database nodes would be affected. I felt physically ill. And then I remembered we've been running Chaos Monkey for all these years. My reaction was, bring it on. So what was the outcome? Bruce Wong wrote, of the 2,700 production database nodes, Cassandra database nodes, 218 were rebooted. 22 never rebooted successfully. They bricked 22 Cassandra database instances, nodes. Makes me physically ill just to think about that. And yet there was no customer downtime. And so, again, the only way that this wasn't an accident, this was a deliberate investment in slowification activities to find the most dangerous cases in production, doing planning and practice so that when inopportune things happen, it was just another day. And incidentally, for those of you who have a background in ITIL, there's a famous notion of the service catalog, and they had that working for them too. So at Netflix, they have a service catalog, and if for every service, if it didn't have the email address of an escalation engineer, they would kill the service in the middle of the day. Why? It's better to do it in a planned way to discover that something doesn't have a service owner than to find out in an unplanned way in the middle of the night where the countermeasure, you have to wake up everybody because no one knows who owned the service that went down. So just another magnificent example of slowification. And so greatness is never free. You have to pay, you have to do these things as a matter of daily work. And you see this from Marty Kagan, who wrote this amazing book called Inspired, How to Create Products That Customers Love. He's trained generations of product owners on how to build great products. And he said, you have to take 20% of all engineering cycles off the table. And why would he believe this so fervently? Is because he was the VP of product management at eBay in the early 2000s. And there, he did not ship a major feature in the entire 2 years he was there. Why? Because all the engineers were just trying to keep the site up. And so he said, if you don't pay your 20% tax as you go, you will invariably spend 100% of your time paying that tax, where nothing gets done except for site reliability issues. So slowification includes paying down technical debt, includes drilling and injecting faults into the production environment to see if we are as resilient as we think we are. And it's also encouraging moments where someone thinks, oh, that's odd, right? To actually potentially pause in production so we can do some more deliberate thinking in planning and practice. So that's slowification. Let's talk about simplification. Simplification. So slowification is about moving work and time from production into planning and practice. Simplification, on the other hand, is about partitioning problems so that they're easier to solve by reducing coupling to enable independence of action. And so if this sounds familiar to you, it should, because in the State of DevOps Research, we found that architecture is one of the top predictors of performance. So as measured by what? It is to what degree can we make large-scale changes to our parts of the system without permission from anyone else outside of our team? To what extent can we complete our work without a lot of fine-grained communication coordination, again, with people outside of our team? To what extent can we deploy and release our service on demand, independently, even independently of the services we depend upon? And I love this one. To what extent can we do our own testing on demand without the use of a scarce integrated test environment, which there are never enough of, they're never cleaned up, but worst of all, it couples us to every other component in the enterprise. So if all these things are true, we should be able to do normal production deployments during normal business hours with negligible downtime. And so this came out in 2017. And really what this talks about is independence of action. And one of my favorite case studies of this is what happened at Amazon in the late 90s and early 2000s. So Amazon started off as a pretty simple property, selling primarily books and music. So life is pretty simple then. But fast forward in time, 4 years, and now they're selling books and music, and as you can see, 32 other product categories. So why is this a problem? So consider what the org chart probably looked like. Is on the one hand, you had these e-commerce teams who are owning product page, shopping cart, ordering, returns, and inventory. And then on this other orthogonal axis, you had an ever-growing number of product teams, books, music, digital apparel, and 35 more. And the problem is that we have every team coupled to every other team. So what could go wrong? Dr. Werner Vogels wrote in this famous ACMQ article about the ridiculous situation that the Amazon digital teams found themselves in, where the Kindle and Amazon Music and movies video team found themselves with this ridiculous situation of their customers having to put in a physical shipping address, even though there was nothing to fulfill. And so those teams went to 80 different ordering teams saying, we need to change this. To which they would hear, we can't, we haven't budgeted for it. And so now those teams are stuck in the same way as the checkbox project was stuck, where nothing could get done. And so this is like 3,500 software engineers all coupled to one couch, no one having independence of action. And really, these on the slide here, everyone's smiling. They're not smiling. They're frustrated. They're angry because they can't do what they want to get done. And so you could actually see this in the deployment frequency. In 1999, they were doing thousands of deployments per year. By 2001, it almost ground to a halt. Most deployments did not finish because something went wrong. Some conflict or synchronization problem resulted in them having to abort the deployment. So they're only doing tens of deployments per year. And so what did they do about it? This led to the famous Jeff Bezos memo, then CEO of Amazon, saying all teams must henceforth expose their service only through APIs. No other form of inter-process communication allowed. Anyone who doesn't do this will be fired. And number 7, as reported by Steve Yegge, former senior engineer at Amazon, later Google, he said number 7 was have a nice day. And then Steve Yegge wrote, number 7 is obviously a joke because Bezos doesn't care whether you have a good day or not. But everything else is true. This was all enforced by then Amazon CIO Rick Dalzell, a former U.S. Army Ranger. And so what did that do? It created hard partitions, modular boundaries between those teams, which allowed them to be able to regain independence of action. And you can actually see this in the number of deployments as they partitioned into tens, hundreds, and later thousands of services or microservices. So they went from doing tens of deployments per year to, by 2011, they shocked the world when they described how they're doing 15,000 deployments per day. By 2015, they're doing 136,000 deployments per day. And so let's go back to that couch metaphor. Instead of having 3,500 engineers all coupled to one couch, they chopped the couch into smaller pieces that enables each one of them to work independently of each other. And so one of the most important concepts I learned was this notion of gaining independence of action and reducing the amount of design time coupling so that they can work independently of each other, and it avoids runtime coupling. So when one service goes down, it doesn't take down every other service. Think about Chaos Monkey in the slowification thing. And we see this happening everywhere. We see, as one of my favorite case studies is Scott Havens. He's a director of software engineering at Walmart. His remit and mission was to rewrite the supply chain software for the world's largest company. And so he described how on the item availability page, it required 23 deeply nested API calls, which means that all of them need to run at 4 nines. They all have to respond within 300 milliseconds, which is incredibly expensive. And because the outage cost is so high, they all have to, even though they are architecturally look separate, because the outage cost is so high, they could only deploy one at a time. So it is as bad as if they were actually coupled together architecturally. And so by moving to an event sourcing architecture, it actually relaxed the requirements. So instead of 23 deeply nested API calls, it went down to 2. It reduced the SLA from 4 nines to 2 nines. It relaxed the SLA requirements from 300 milliseconds down to multiple seconds, which actually saved them tens of millions of dollars and made it possible to actually test every one of the things independently each other in unit tests. So just a magnificent example of how important decoupling is. So one thing I'll just talk about before leaving this section is, just one of the reasons I love the couch metaphor is it explains two what appear to be simultaneously mutually contradictory cases. So we learned about the Amazon e-commerce example where we had too many people coupled to one couch, and the countermeasure was to partition it. But there's a curious counterexample that they gave last year, which was as if they had divided the couch into 2 small pieces. This is the Amazon Prime Video story, where it described how they were able to reduce the cost of the AV monitoring service by 90% by moving from microservices down to one monolith. And what this shows is that if you partition something too small, then all your time is spent in coordination and communication, and in their case, transport. The 90% cost reduction is because they were copying the same data in and out of S3 storage buckets, which is very, very expensive. And so by putting it back into a monolith, we reestablish locality and coherence so that the data stays in one place, and resulting in a 10x cost reduction. So we glue the couch back together, right? And we get all these amazing benefits. So briefly, why is this so important? Something that blew my mind, one of the most important aha moments is that was that when Steve Spear told me that, hospitals are just so notoriously dangerous these days. But believe it or not, hospitals were much safer back in the 1950s. Why would that be? It's because back then, there were basically 2 functional specialties. You had doctors and nurses in layer 1. You had very little technology. You had X-ray machines, which wasn't, didn't require a lot of, which aren't terribly complex or fast moving. And so under those conditions, you can get away with a pretty simple layer 3 coordination and management system. So fast forward 70 years, now we have 20 different functional specialties just among clinicians. You have nursing, supply chain, pharmacy in layer 1. At layer 2, you have so much more technology. It's not just X-rays, it's MRI machines, CAT scanners, blood thinners, right? This is why it's called imaging, not radiology. So imagine how much more sophisticated the layer 3 wiring must be to accommodate all of that. And so we have the same explosion and complexity happening today in technology. So the job of the technology leader is not getting easier. It is getting more complex because we have more and more functional specialties. We have AI, ML ops, we have prompt engineering, adding even more functional specialties that need to be shifted left, shifted right to get the right outcomes. So my lesson is really think about how important it is for our technology leaders, for we as a technology leadership community, to have this judgment of high energy, high standards, great in the large, great in the small, and love walking the floor. So I guess I can share with you this one caution. The other big aha moment working on this project was my fear of shared services and queues, right? So we know how good platforms are. So we can get environments on demand, VMs on demand. We can deploy on these amazing CI/CD pipelines, everything in these platforms. Consider the opposite. A friend of mine, she told me the story about how they had these SAP role engineers, which almost every business change required one. They had an SLA of 2 weeks. The actual was around 11 weeks. They had a net promoter score of -87, which I didn't actually know the net promoter score could go negative. I thought it was 0 to 100. It's actually -100 to 100. So she said, we love shared services, but not there, right? If it's not automated. So what do they do? She broke up the team and embedded the SAP role engineers in the business units to reduce contention. And suddenly the problem disappeared. So again, just another great evidence of how these technical maestros are able to see the wiring and diagnose quickly what goes wrong and how that can lead to better outcomes. Same people, but wildly different outcomes. All right, so Simplification, things like agile incremental delivery, modularization, linearization, like the CI/CD pipeline, creates independence of action from developers, from security engineers to ops and infrastructure. That is the mark of modularity, of simplification. So let's go to the last mechanism of performance, which is amplification. So slowification is about moving problem solving in time from production into planning and practice where it's safer. Simplification is all about partitioning what is being worked on so it is safer and easier to solve and faster. And then amplification is enabling important signals to get to where they need to go. And so if that sounds familiar, it should, because what Dr. Ron Westrom found as a sociologist who studied aviation safety, nuclear reactor safety, medical safety, what he found was that that one of the top predictors of safety was culture. And he described the worst performing organization as having these characteristics. We hide information. Messengers of bad news are shot. We discourage bridging between teams. We cover up failures, and new ideas are crushed. In the middle, he found something that he called bureaucratic cultures, where we create processes to protect people, to mete out justice, which sounds pretty good, but it's not as good as what you found in the highest performers, where we seek information. We train messengers to tell bad news. We encourage bridging between teams because, say, in our work, InfoSec is not just InfoSec's job. Just like uptime and availability isn't just Ops' job, it's everybody's job. And when failures happen, it causes a genuine sense of inquiry and new ideas are welcomed. So I love this. This is actually one of the second top predictor of performance in the State of DevOps Research. But as Dr. Westrom said, culture is sometimes very difficult to talk about because it's gossamer and ethereal, meaning it's not very concrete. And so it's very difficult to diagnose non-concrete things. And so our treatment of this in the Wiring the Winning Organization book was to recast this as information theory as framed by Dr. Claude Shannon. We said information theory signals must be generated, it must be transmitted, and most importantly, received, right? We measure the success of any communication by the receiver and to what degree is it acted upon and the corrective action confirmed. And the reason why I love this is that this is something that we as engineers are really good at. So when something goes wrong, we can ask, is this a signal generation problem? Do we just not know? Is this a transmission problem? People are not going to tell bad news because messengers of bad news are shot. Is this was the message received? was it prioritized? Was it acted upon quickly enough? And did someone actually bother to see if the corrective action or the help satisfy the call for help? And so in the book, we outline one of my favorite case studies. That's just astonishing. This is in the US when Winter Storm Elliott hit. Thousands of flights were canceled. But what was astonishing is that as the days went by, every major air carrier, the number of cancellations went down, except for Southwest Airlines, where the number of cancellations continued to climb. And one of the major contributing factors was the crew scheduling system. Basically, whenever a pilot was in the wrong place at the end of the day, they had to call the crew scheduling system to tell them where they were. But the hold times were sometimes 30 minutes, in one case reportedly 22 hours. And so whenever that information didn't get into the crew scheduling system, when they opened up flights the next day, they had to cancel a flight because the plane was in the wrong place. And so they had to fly empty airlines around. So this is such an amazing example because it shows what happens when information doesn't get to where it needs to go. That happens in layer 3. And it shows that the control overlay has to be faster than the production environment. So one of the best examples of this was Adidas. During the pandemic, Fernando Cornago, VP of Digital Tech, described how e-commerce became the only functioning channel to the customer during the pandemic as every retailer was shut down. And they had an increasing number of outages. And he described his embarrassment that sort of in an ITIL-like way, he had to approve as one of 3 VPs every major production change. So the 6 I's required to approve changes. And his reaction was, what do I know? I know nothing, right? And so we need to move the decision rights to the edge, to those engineers who really know what, how, when, and why. And so this became the re-engineering of the production system that supported Adidas.com that enabled them to safely, again, deploy more and more production changes quickly, safely, and securely. So another example of moving decision rights to where the information is, as opposed to moving information to where the authority is. So all of these are just fantastic examples of amplification. So amplification is creating these energetic feedback loops where feedback is going to the right place at the right time in an actionable format so people can learn, versus feedback loops that are weak, slow, non-existent, or go to the wrong people, where failures go undetected and actually grow over time. So to conclude, the reason why I find this so satisfying is that they say the goal of science is to explain the most amount of observable phenomenon with the fewest number of principles, confirm deeply held intuitions and real surprising insights. And that's what this book did for me. To show that, in all these bodies of knowledge, there's actually three mechanisms that at the heart of it that enable organizations to go from good to great. And this is what unlocks what magic these organizations, these high performers have, that enable people to do extraordinary things more than any individual could ever do alone, that fully unleash and liberate people's creativity and problem-solving capabilities, versus those organizations that somehow constrain or even extinguish entirely the full problem-solving capabilities of the people within them. And so, as Winston Churchill said, we shape our buildings and thereafter they shape us. So too is it with the organizational wiring. As leaders, we create the social circuitry that everyone works within. And without vigor and optimism and a relentless sense of improvement, it forever shapes us. And I'm just so happy with the way this book has resonated with so many people, not just within the DevOps community, but people who are outside of it, whose opinions I very much respect and admire. My last thing I want to share is that if any of this interests you, we're holding the fantastic Enterprise Technology Leadership Summit, formerly known as DevOps Enterprise. We're holding event number 21 in Las Vegas in August 20th. And there are so many fantastic experience reports from organizations and technology leaders I admire, and a whole bunch of subject matter experts teaching us on generative AI, things that we need to know to help our organizations win in the marketplace. So if you're interested in these slides, links, in any video I've talked about, just send an email to realgenekim@sendyourslides.com, subject line DevOps, and you will get an automated response within a minute or two. So with that, I'd love to thank you so much for your time. I'm going to turn it over to Rick for Q&A, and thank you.
That's very inspiring, Gene. Thanks a lot for this talk. We do have quite a few questions, so let's see how many we can address. And it could be it's well possible that some others are digesting all the nuggets that you shared today, and they will pour in some additional questions. But let's start. We have one question, very interesting. I think in general in the field we're in, also when you look at the data ecosystem, we have a lot of examples that we look up to. Those examples are typically from digital-first organizations such as Google, Netflix, Facebook. But it's sometimes difficult to compare the culture and capabilities of such organizations to what we can call a more normal or corporate organization. So imagine you take this to banks in some countries that still work with the majority of the processes manually or based around paper trails. What would you recommend to those organizations that don't have yet a digital DNA?
Yeah, no, in fact, as I mentioned in the presentation, my area of passion for the last 10 years is studying not the digital first companies, but organizations that have been around for decades or centuries. And incidentally, the oldest organization, commercial organization that presented was Barclays, founded in the year 1695. That predates the invention of paper cash in the West. But the very oldest organization was UK HMRC, so that's His Majesty's Revenue and Customs Service, founded in the year 1200. So, I just find it so exciting that, these organizations are better serving society, better serving their customers by using digital technologies to win in the marketplace or advance their societal goals. And so, the advice is, I think the quip is every company is a technology company these days. That's probably more or less true, and that all these technologies enable people to work better, sooner, safer, happier, and I think that's so true. And I think with the advent of AI, it's getting even more true. And one of the books I really loved reading was called Co-Intelligence by Dr. Ethan Mollick. He wrote a fantastic book called Co-Intelligence, and many people are taking him up on his advice, saying, board chair people, CEOs, you have to use ChatGPT. You should be recommending everyone in your organization to at least play with it, so that you can get a sense of which things could make your life easier, make tasks faster. And so I think that can only help our movement.
Wow. Yeah, thanks. I have one question related to the great example you shared around the Amazon re-architecture.
Yes.
So you basically said, in my own words, that they needed some, with these rules that were sent in this email, some strong top-down leadership actually to make sure that this simplification took place. Would you argue that in most organizations to actually make sure that simplification really is achieved, that you need, let's say, ways to disrupt the current way of working or the current operating model? And what kind of leadership tactics would you recommend there? Because people might think that the more facilitative servant leadership style is preferred in agile DevOps context, but this is a nice counterexample you showed from Amazon, from the top, right?
Yeah, no, I think it is. That's such a great observation. And I think that's why I love the socio-technical maestro instrument from Dr. Ron Westrom, is that whether it's Jeff Bezos at Amazon, Bill Gates did the same things, very similar, during the summer of worms, where basically every Microsoft product was being mown down because of security vulnerabilities in the early 2000s. It happened to eBay in the early 2000s, LinkedIn, where a strong business technology leader said, stop what you're doing and instead work on, slowify. And I think the reason why I love the metaphor of organizational wiring is that it says that the engineering mindset is as useful for hydraulic circuits, mechanical circuits, electronic circuits, software, as for how we wire our organizations together. And when the organizational wiring gets messed up, right, it's that person's job whose responsibility it is to fix the wiring, right? And sometimes it requires draconian things, right? Bill Gates said, every engineer, if you have to choose between fixing a security issue or shipping a feature, always fix the security issue. No new features in Windows, Office, Exchange, .NET for a year, right? So, I think sometimes when the organization needs to be reconfigured, it takes that. This is not a place for consensus.
Yeah. I fully agree, but it's good to emphasize this. Another question relates a little bit to future trends.
So actually, can I add one more thing?
Yeah, sure. Yeah.
And so I don't think that's inconsistent with this need for psychological safety. There was a famous meeting at Amazon called the Tuesday morning meetings, where they would it's where any organization that had an issue, and if they didn't have an issue, they would spin a wheel of to pick which group would report on their KPIs. And the goal was to make sure that there's attention focused on engineering excellence. And by all accounts, anyone could attend this, and people loved attending it because, one, you learned a ton. Two is that you would pick up mistakes made that you don't want to make in your team. And so that led to a widespread adoption of practices. And so, the notion of the API application of Amazon, the Tuesday morning meetings, I mean, they're all, I think can be explained by the need to psychological safety and the need to sort of have signals travel quickly. Sorry.
That makes sense. So we have time for one last question, and then we have to finish because of the time. Maybe quickly in 1 minute, Jean, any additional trends you see in the future, talking about the field of DevOps that organizations should, let's say, embrace or prepare for?
Yeah. One of the things I find so exciting is that I gathered about 50 technology leaders in April, and fully 1/3 of them are now leading or significantly contributing to the most important generative AI projects. And I find that no accident, that the same pioneers who push the boundaries of performance using DevOps are the ones being asked to help figure out how we can use generative AI technologies to win, because they have the best long-term interests of the organization at heart. So I would be skeptical.
Perfect sense. Yeah, I think we have to round it off, right, Joey? I think we're near the end of the talk, and we have some award ceremonies and our talks coming up. Thanks a million, Jean, for this insightful talk. Lots of nice inspiration for the attendees, and For those who have additional questions, please share them to us and we can answer them offline. And thanks a lot and enjoy the rest
Thank you so
of the day.
much and have a fantastic rest of the conference.
Thank you.